Hello everyone, welcome to another session of our calculus class. This is Mr. Lemisailo, your calculus teacher. During our previous week, we focused at chapter 7, section 2, which was anti-differentiation by substitution. During this time, we will move on to section 7.3 and study about anti-differentiation by parts. You may open your textbook, page 345. The objective of our lesson is solving for the unknown integrals using integration by parts and to use tabular integration method to integrate complex functions. Anti-differentiation by parts and integration by parts are exactly the same. So throughout our discussion, we'll be using these two terms interchangeably. This is the integration by parts formula. The integral of u times dv is equal to u times v minus v times du. Okay, now let's see how to assign functions into u and dv. U takes the function which is easy to differentiate, and the derivative goes to 0 at some point upon multiple differentiation. And dv takes a function which is easier to integrate. Integration by parts formula is the product rule for integration. And during assignment of functions into u and dv, we have to use this order of functions. It is written in a shorthand form, LIPET. L stands for logarithmic function or the natural logarithm. I stands for inverse trigonometric functions. P stands for polynomial function. E is for exponential. T is for trigonometric functions. Good. So this LIPET helps you assign a function into u, not into dv. So let's say, for example, that you are integrating the product of two functions. If your two functions are polynomial and exponential, since p comes before e in the order of letters in LIPET, so the polynomial function should be assigned to the function u, and the other one should be assigned to dv. Let's have a look at the first example of our lesson to understand how the integration by parts formula works. Integrate the function x times cosine of x dx. Okay, the first thing you do is you write the formula for the integration by parts. With the help of LIPET, you have to assign functions for u and dv. It's obvious that x is a polynomial function, and in the order of letters in LIPET, the polynomial function comes before the trigonometric function cos x. So you should take the function x. When I say u, I mean the function u. And dv takes cosine of x dx. And the next step, you differentiate u is equal to x to get du is equal to dx. And dv is equal to cos x dx means you have to find the antiderivative of cos x, which is sine x. Next, write your formula, and now you have four of them. U, V, du, and dv are ready. Properly place them in the right positions, and you got this one. Good. Now it's easy to deal with the integral of sine x. The integral of sine x is minus cos x. So the two minuses will add up to give you plus cos x. And your final answer is x sine x plus cos x plus c. Moving on to the next example, integrate ln of x dx. Good. As we did in example 1, we write our formula for integration by parts, and LIPET helps us assign functions into u and dv. Ln of x is a natural logarithmic function, and that's represented by the letter L, the first letter of LIPET. So as we said, that u takes the logarithmic function ln x, and dv takes dx. U is ln x means if you differentiate both sides, du is equal to 1 over x dx, because you remember that the derivative of ln x is 1 over x. And dv is equal to dx means if you take the integral of each side, it means v is equal to x. Good. Now write the formula again and place the values of u, the expressions for u, v, du, and dv to get ln x times x minus integral of x times 1 over x dx. x times 1 over x in this new integral is 1, and the integral of 1 is simply x, because when you derivate x, it gives you 1, and your final answer is x plus x minus x plus c. Example 3, x squared, integrate x squared times e to the power of x dx. Okay, assign your functions into u. Okay, we assign x squared into u because x squared is a polynomial function, and e to the power of x is exponential. P comes before E in the order of letters in Lipet. So U takes x squared and dv takes e to the power of x dx. Good. Now, as we always do, differentiate du to get to x dx and find the antiderivative of e to the power of x, which is itself. Now we will plug the expressions in the right positions, and you will get this function x squared e to the power of x minus the integral of e to the power of x times 2x dx. Good. Since 2 is a constant, it can be factored out and it can be written as a coefficient of the integral. Good. I want you to pay attention to the new integral you see now next to the coefficient 2. It is the integral of product of two functions, x and e to the power of x, which opens up another round of integration by parts, where we have to assign u a polynomial. U should take the polynomial x, and du should take e to the power of x dx. If u is x, it means du is equal to dx, and dv is equal to e to the power of x dx means the antiderivative of e to the power of x is itself. So to rewrite this for this expression by another formula of integration by parts, which is uv minus integral of v times du. If you properly plug them in the right positions, you get this one. Distribute -2 over the terms inside the bracket, and the integral of e to the power of x is e to the power of x itself, and then your answer is x squared e to the power of x minus 2x e raised to x plus 2 times e to the power of x plus the constant of integration. Let's move on to the fourth example, where we integrate the product e to the power of x times cos x dx. Here we have two functions, e to the power of x, which is exponential, and cosine of x, trigonometric function. So Lipet will help us assign the function. The exponential should go to the function u, and the trigonometry should go to dv. Good. Derivate u, you get e to the power of x itself. Antiderivate cos x, then that gives you sin x. Now write your formula for integration by parts and properly plug in the u, v, du, and dv's in the right places to get this expression. Now look carefully at this new integral, which is the integral of sin x e to the power of x. It is the integral of the product of two functions, again, which opens up another room for integration by parts. Good. Let's repeat the process again. Assign u is equal to e to the power of x, and dv is equal to sin x. Du will be e to the power of x itself. The antiderivative of sin x, I hope you remember, is minus cos x. And now we have to write uv minus integral of v times du properly from our new assignment, and we get this expression. Distribute the negative sign over the terms inside the bracket to remove the bracket, and you get this expression again. I want you to pay attention to these highlighted term integrals now. The integral we started with, and the new integral we ended up here on the right side are exactly the same, or they are like terms. So we can move them both to the left side. Since they are like terms, they can be added up together to give us 2 times the integral of e to the power of x cos x dx. Good. So to isolate the integral, you can divide each side by 2, and your integral is e to the power of x sin x plus e to the power of x cos x divided by 2 plus the constant of integration. Well, now let's move on to the tabular integration method. The tabular integration method works for integrals of the form f of x, g of x, where f of x differentiate to 0 at some point when you continue your differentiation multiple times, And g of x is the function which will again repeatedly integrate, as we'll be looking into it on the upcoming example. All right, let's look into example 5, where we will see how to apply the tabular method of integration. You remember we have integrated x squared times e to the power of x by using the normal integration by parts formula, uv minus integral of v times du, but it took us a while to get the answer. The tabular integration method cuts the steps short, and we'll get the answer in a very brief time. Let's go. Good. To apply the tabular integration method, you have to prepare these two lines, and on the left side you have to write the function f of x, which derivates multiple times until it reaches 0, and on the right side you have to write g of x again, which integrate multiple times. Good. Which of these two functions derivate multiple times to give you 0? It's obvious that we have to take the polynomial function on the left side. So x squared derivates to give you 2x, 2x derivates to give you 2, 2 derivates to give you 0, and there you stop. On the right side, take e to the power of x for g of x, and this time we continue to integrate it instead of derivating it. To integrate means to find its antiderivative. The antiderivative of e to the power of x is e to the power of x itself. Continue again until you level up with 0 on the left side. Okay, in your next step, you need to write plus and minus signs alternatively. And finally, you need to multiply the diagonal expressions, starting with expression on the top left side, which is x squared. So start with x squared, which is a positive, multiplied with e to the power of x. You get x squared times e to the power of x, plus negative 2x times e to the power of x gives you minus 2x times e to the power of x, minus 2x times e to the power of x. Lastly, you have plus 2 times e to the power of x. It gives you plus 2 times e to the power of x. And lastly, we have to add the constant of integration. Good. Let's have a look at the last example of our lesson. This is the integral of x cubed times sine x dx. If we try to apply the uv minus integral of v times du type, it may take so long, and also needs a large space to get the final answer. But thanks to the tabular integration method, we can finish this one in a very brief time. Okay, let's start with the polynomial function on the left side and continue to derivate it. The derivative of x cubed is 3x squared, and the derivative of 3x squared is 6x, and the derivative of 6x is 6, and the derivative of 6 is 0. Good, we'll not go beyond this one. On the right side, we take sine x and we integrate this one continuously. The integral of sine x is minus cos x. Again, find the integral of minus cos x. It is minus sine x. Again, find the integral of minus sine x. It is cosine of x, because the derivative of cos x is minus sine x. Proceed to find the integral of cos x, which is sine x. Good. This loop doesn't stop. It continues indefinitely, but as we did earlier, we will stop the integration when we level up with 0 on the left side. Good. Next, we have to write the plus and the minus signs alternatively before we start the diagonal multiplications and find the sum. So we got x cubed times minus cos x, which is minus x cubed times cos x, plus the minus times minus in the next diagonal cancel out to give you plus, so you have 3x squared times sine x. And in the third step, you have 6x times cos x, which gives you 6x cos x. It's a plus sign. Lastly, you have minus 6 times sine x. It gives you minus 6 times sine x plus the constant of integration, which is c. This brings us to the end of the lesson. I hope you got a better understanding on the topic. See you next time.